I wanted to add one more thing to the reflections that we did the other day, and I wanted to add what's called a reflection mapping. A reflection mapping is basically a sentence, kind of an algebraic sentence that tells us how the points move. Now, we did these with the translations, and I'll review that real quick. The translation mapping looks something like this here. It basically said there we go. It basically said how every x, y pair, every coordinate, every point moves. Anything that's added or subtracted onto the x tells me how it's moving left and right, and anything that added or subtracted from the y tells me how it's going to move up and down. So what this mapping says to me when I read it, it says, hey, every point moves 4 to the right and 5 down. So some of the things that I asked you guys to do were to simply write that out and tell me, how do these things move? So this mapping says that every point moves 4 to the right and 5 down. And that's it. You're done. There's nothing else to it. The reflection mappings are kind of a double-edged sword. There's only 2 of them, ever. There's only 2 reflection mappings that you're ever going to see. They're not as infinitely possible as the translation mappings because it has nothing to do with how many units the figure moves. It has more to do with where the original point is at and where the new point is at in relationship to that. So there's only 2 reflection mappings, but the thing that I find confusing about them is how they're actually written, because it looks like it has a lot to do with negatives, and it really doesn't. It's more about position. So these are the only 2 reflection mappings that you're ever going to see. The first one says, hey, every XY pair moves, and the X is going to stay the same, but the Y is going to change. And the second one says basically the opposite. Every XY pair is going to move, the X is going to change, but the Y is going to stay the same. Now, I think it's a little bit easier if you actually see what these do, what I'm talking about here. So I'm actually going to perform 2 reflections on just a single point. And we're not going to do like a whole figure and make this overly confusing, just keeping it pretty straightforward here. So I'm going to take this point 3, 5. Now, if you plot the point 3, 5, it is right there. Okay, that might be a little hard to see. So let's try zooming in a little bit. So I'm going to take that point 3, 5 and I graphed it, right? So now what I want to do is I want to take that point and reflect it over the x-axis. Now the x-axis is your horizontal one. So when I take a point that's above and I reflect it below, what's actually changing? My left and right direction isn't changing at all. What's changing is the actual vertical distance. So we're reflecting across the horizontal line, but the vertical number is going to be the one that changes. So my point 3, 5 is 5 units above the x-axis. When I reflect it, it's now 5 units below the x-axis. So that mapping is actually the one that reflects the y. The x-coordinate stays the same. This thing doesn't move left and right at all. It just moves vertically from above the axis to below the axis. So my mapping on that one would have been this one here. This top one is what reflects across the x-axis. So this guy right here, this one goes across the x-axis. So changing the y reflects across the x-axis. That's what I have a hard time keeping straight. I have to stop and think to myself, okay, I went across the x-axis, the y coordinate is the one that changed. So it's kind of a logical conclusion, I think, that the second one, my second mapping here is the one that goes across the y-axis. Now, this isn't saying that the x-coordinate is going to be negative. It's going to be the opposite of what it originally was. Same thing here. This top mapping isn't saying that the y-coordinate is going to be negative. It's going to be the opposite of what it was. So you've got to kind of stop and think on these and make sure that you're kind of getting that straight in your head. So just to illustrate here, I'm going to take my point 2, 7. 2, 7 is way up here, right? And I'm going to flip that this time across the y-axis. That should be the y-axis there. It says x, but it should be the y. Let's fix that. So I'm going to flip this thing across the y-axis. So my point here is going to go over here. So what actually changed on that point? Well, the x-coordinate is now its opposite. And that goes vice versa too. If I had started at negative 2, 7, when I reflected it, now it's going to be at positive 2, 7. So the 2 mappings there's only two of them, right? The two mappings, whether it changes the x or whether it changes the y. So let's actually do one of the points or one of the problems from the day before. I'm going to take this and I'm going to reflect every point across the x-axis. So I'm going to take my 3 points of my triangle and I'm going to flip them below the x-axis. So this point here is at 5, 4. So when I reflect it, it's at 5 still, but now it's at -4 down here. And I'm going to do this one is at -2, 6. So now it's at -2, -6. And this one is at 7, 8. So now it's at 7, -8. So I'm going to go down to my shape tool. I'm going to draw my triangle. Why is that white? That's hard to see. Let's try that again in black. So I'm going to draw the 3 sides of my triangle, make it nice, neat, and sharp with my my line tool here. All right, and I get a perfect copy of the picture above, but now it's below. So what would the transformation mapping be? So my original point, all right, so the mapping for this last one is going to be every XY pair is going to move to. Now what happened? Did the X's change or did the Y's change? Did it move left and right or did it move up and down? Well, this thing moved from above the X-axis to below the X-axis. So my new mapping is going to be X, -Y. Now, that doesn't mean that the Y is actually negative, because if I reverse that, it would go from below to above. It's switching opposites.